8.1, hypothesis testing, when we are talking about difference between means. Very well, what we learned so far? We learned that if we have just one population, consider the population of all students in the answer, population 1. You can compare this population with another population, like population of students in West Valley College. We're interested in, for example, comparing the means of these two populations or comparing the proportions of these two populations. Very well. First of all, let us talk about independent and dependent samples. Then we're going to get back to the big picture of comparing two population means. In previous chapter, we studied method for testing a claim about the value of a population parameter. Again, a population parameter is either the mean or proportion or standard deviation or variance. In this chapter, you learn how to test the claim comparing parameters from two populations, like comparing two population means, comparing two populations proportions, comparing two populations standard deviation, or comparing two populations variances. Very well. We're going to talk about types of samples. Definition. Two samples are independent when the sample selected from one population is not related to the sample selected from the second population. Take a look at this. Here you have 4 students taken from D'Anzo College, and they are just attending D'Anzo College classes. Here you have 1, 2, 3, 4, 5, 6, 7 students from West Valley College. They're just taking classes in West Valley College. No student from D'Anzo College is taking any class in West Valley College, and no student from West Valley College is taking any class in D'Anzo College. This is an example of independent samples. We say that two samples are dependent when each member of one sample corresponds to a member of the other sample. Dependent samples are also called paired samples or matched samples. Very well. As you can see, here you have a graph of dependent samples. Example 1, independent and dependent samples. Very well. In the first example, sample 1 is the weights of 65 college students before their freshman year begins, and sample 2 includes weights of the same 65 college students after their freshman year. Okay, as you can see, since we are using the exact same number of students, this sample, this set of samples is actually a dependent set. You are using the exact same students before and after their freshman year. Example part 2, sample 1 scores for 38 adult males on a psychological screening test for attention deficit hyperactivity disorder. Sample 2 scores for 50 adult females. Okay, males and females. You can just stop here. These two samples are independent from each other. Very well. An overview of two-sample hypothesis testing. In this section, you'll learn how to test a claim comparing the means of two different populations using independent samples. So there is no connection between those two samples. So in this case, we usually say that, hey, mean of the first sample is equal to the mean of the second sample. Mu sub 1 minus mu sub 2 is equal to 0. It means that the mean of the first population is equal to the mean of the second population. As usual, when it comes to populations, we have to work with test statistic coming from the first population, coming from the second population. So you're going to say, hey, x1 bar, the first sample mean, is equal to x2 bar, the second sample mean. Take a look at these two populations and the samples taken from these two populations. We know that these two populations are different from each other, and you're taking two independent samples. The first population is population of male college students. The second population is population of female college students. You're taking sample from the first population, sample from the second population. You calculate the mean standard deviation of the first sample, which is x1 bar equals to 85, S1 standard deviation 15, and N1 is equal to 200. For the second sample, after collecting the data, you're just calculating the mean and standard deviation. Mean is 81, standard deviation is 17, and sample size is 250. Your goal is to form null and alternative hypothesis. Very well, we're going to use a sampling distribution when it comes to two independent samples working with the difference between their means. So you randomly select different samples from the first population, from the second population. You're going to calculate the means of those samples and finding the difference between them. Then you can form a distribution which happens to be a normal distribution. Very well. Definition: for a two-sample hypothesis test with independent samples, the null hypothesis, H sub 0, is a statistical hypothesis that usually states there is no difference between the parameters of two populations. So they are going to be the same. The null hypothesis can be written as less than or equal to, exactly equal to, greater than or equal to. Again, when it comes to null hypothesis, you must have equality. If you don't have equality, it means that you have your alternative hypothesis. An alternative hypothesis, H sub A, says there is a difference between those two population parameters. Mathematically, null hypothesis says the first population mean is equal to the second population mean. Alternative hypothesis, which is the opposite of equal to, not equal to. They are not equal to each other. If it's the case that your null hypothesis says the first population mean is less than or equal to second population mean, its opposite is greater than. If it's the case that your null hypothesis saying that the first population mean is greater than or equal to second population mean, its opposite is going to be less than. Again, remember that the graph depends on your alternative hypothesis. In this case, that you don't have equality, it means that it is less than or greater than. So it's a two-tailed graph. In this case, you have a right-tailed graph, greater than. And in this case, it says less than, so you get the left-tailed graph. Very well. Okay. So, two-sample z-test for the difference between means. Very well. We will learn how to perform a z-test for the difference between two population means, mu sub 1 and mu sub 2, when the samples are independent. Guys, it's very important that you have independent samples. When we have dependent samples, we have to use a different formula. Being independent is very important. These conditions are necessary to perform such a test. So, first of all, the population standard deviations are known. So, sigma sub 1, sigma sub 2 are both given. You have both of them. 2, the samples are randomly selected. Okay, randomness to avoid any bias. Samples are independent from each other. And the populations are normally distributed, or sample size are greater than or equal to 30. When these conditions are met, the sampling distribution for x1 bar minus x2 bar, the difference of the sample means, is a normal distribution with mean and standard deviation or standard error as shown in the table. Mean is mu sub 1 minus mu sub 2, and standard error is square root of sigma 1 squared over n1 plus sigma 2 squared over n2, and all of them are inside the radical. Perfect. Okay, let's take a look at the definition and the guideline. For a two-sample z-test, when samples are independent from each other, the test statistic is x1 bar minus x2 bar, and standardized test statistic is z equals to the difference in the sample means minus the difference in population means, which is 0, divided by standard error. Standard error is equal to this radical. So you calculate the standard error and you write it on the denominator. On the numerator, you have x1 bar minus x2 bar. As you know, if z, this standardized test statistic, is inside the rejection region, you reject your null hypothesis. So take a look at the guidelines. First of all, check to see if sigma 1, sigma 2, or population standard deviations are given. Then make sure samples are random and independent from each other. Make sure the populations, both of them, are normally distributed, or the sample size are greater than equals to 30. Then state null and alternative hypothesis. Identify your alpha, level of significance. use ztable to find critical values. Then you need to find your standardized test statistic, which is equal to x1 bar minus x2 bar. This is 0 divided by square root of sigma 1 squared over n1 plus sigma 2 squared over n2. If z is inside the rejection region, you reject your null hypothesis. Let us go over one example, see what's going on. So suppose you have two populations and you're taking two samples from each population. The mean of the first sample is 47.77 and its sample size is 250. The second sample mean is 48.66 and the sample size is 250. Question says, suppose the first population standard deviation is 1045, the second population standard deviation is 1350. Your alpha is 5%. Do you reject or fail to reject the null hypothesis? Okay, in the first line, it says a credit card watchdog group claims that there is a difference. It means that mu1 is not equal to mu2. There is a difference between two means. This is your alternative hypothesis. So you can form your null hypothesis. So this is the claim, which says mu1 is equal to mu2. So here you have a two-tailed graph because mu1 is not equal to mu2. Since you have a two-tailed graph and your alpha is equal to 5%, you divide alpha by 2, 0.025, 0.025. You look at your z table, 0.025, and you find the z value, critical value, related to this area, which is negative 1.96. Perfect. Since we have a two-tailed graph, we have a negative and positive critical values. And rejection regions are on the left and right-hand side. Then we need to form standardized test statistic, which is z equals to x1 bar minus x2 bar minus the difference between two population means, which is 0. You always assume that this difference is equal to 0. Divided by square root of sigma 1 squared over n1 plus sigma 2 squared over n2. So we plug in the values that we have. x1 bar, x2 bar, you subtract these two, divided by square root of sigma 1 squared, so sigma 1 is given, you raise it to 2, divide by n1, n1 is 250 plus sigma 2 squared, which is equal to 1350, you raise it to 2, divided by 250. After doing the algebra, the z value is negative 0.82. Okay, since negative 0.82 is outside the rejection region, this is the rejection region, we fail to reject the null hypothesis. So we fail to reject the null hypothesis interpretation. There is not enough evidence that at 5% level of significance to support the group's claim that there is a difference in the mean credit card debts of households in California and Illinois.